Okay, good morning everyone. Welcome to the Powered by Space, Space Technologies and Energy Transformation Seminar to the Energy Week here in Vaasa. My name is Heidi Kuusniemi, I'm from the University of Vaasa and I'll be moderating this seminar.
Yeah. Hello everyone and welcome. My name is Ratan and good morning to all those joining from the time zone here, and also good afternoon and good evening for others watching our stream live from other parts of the world. Since we have a very limited time, Harry will take over from here. Thank you and welcome.
Thank you, Ratan. We have a very exciting program with a lot of information, so we will right away move ahead. We will open with a short opening to tell you a little bit background about why this seminar is important and why it is here in Vaasa in the Energy Week. Then we have exciting presentations for you ahead. And then after the presentations, we will have a panel discussion focusing on the relevance of space for the successful energy transition. But to give a little bit of a background, why this seminar is happening here in the Energy Week, it's due to the Kvarken Space Center that has been built the past few years here in the Kvarken region. The region between Vaasa and Umeå, with our partners then, for example, from Espoo in southern Finland and then in Kiruna in northern Sweden. So the Kvarken Space Economy EU Interreg Botnia Atlantica project is building a Kvarken Space Center in Finnish-Swedish collaboration, and our goals are to foster long-term space-based data utilization in the Kvarken area, and of course for the energy cluster here in the Vaasa region, we are bringing space also to the energy sector. We want to develop the local expertise here in Finland, in the Ostrobotnian regions, and then together with our Swedish partners in Västerbotten and further. And also we want to develop the cooperation networks beyond region, also to the international level. What we have been doing in our project so far, we have been active in providing initial and also long-term industry support to the region, also for the energy cluster. We have also demonstrations in our project that we have been focusing on. In our kvarkenspacecenter.org website, we have a data portal of portals where we are providing tools and data and demonstrations how to utilize space data to the fullest. And then we have been designing our own CubeSat mission called Kvarkensat, which you see displayed here. And its ground station is here in Vaasa. The plans are that it will be launched from Kiruna in spring next year if everything goes well. If you're interested in more, please come and talk to us. We have lots of our Kvarken Space Center representatives here today. At the Energy Week, you can come and talk to us from different organizations, or then you find more information on the website kvarkenspacecenter.org. So, the Kvarken Space Center activities are why we are here. We want to bring now new space and space-based data utilization to the energy sector and to benefit the sustainable energy and the energy transition. We will start with our first presentation, which focuses on the Kvarken region. So Jari Ratilainen, project manager from the Muova Design Center at the Vaasa University of Applied Sciences. The floor is yours.
Thank you, Heidi. Am I shouting? So, we are doing this within the confines of the Kvarken Space Eco project as well. So, the basic idea is to build a new space innovation ecosystem, an industry and research hub for new space innovation. What we are aiming is indeed a local, regional and international dimension for it. It is still emerging. We are looking for industry research and company engagement especially, and of course we see this as a high potential for the area as well. So what we are actually trying to establish is indeed an interface for cross-border activities and shared capabilities. So we try to build like a capabilities-based hub for these activities, and also to build it so that we would have an active and attractive hub for collaboration, finding new partners outside of the immediate area as well, and interesting to funding as well, and new business opportunities within diverse industries. So we are doing this in collaboration with within the project and with Swedish partners as well. So it is not just to try and build something for the Finnish market or with the Finnish companies, but do a proper like international endeavor out of it and reach for the global markets. So local capability building and support, cross-border collaboration, shared innovation infra, and aiming for the international market and building this competitiveness together is the basic objective of the hub. And we are indeed trying to attract actors from across the like value chain and outside of the triple helix, like normal triple helix as well, to make it so that we can also attract new entrepreneurs and startups, capital outside of the like normal academia and industry as well. We have been talking with the companies quite a lot and just compiled a basic list of some of the issues that keep popping up with all of the discussions that we are having, and these are kind of the basic topics that keep coming up again and again. So what we see that the space-based data can be utilized in quite many industries, and it's for the Vaasa region especially, looking into the energy cluster and energy sector or maritime as well, looks extremely promising. So we are trying to establish this with actual activities and functions and capabilities as well. So the first contact points into this innovation hub or network is indeed through this infrastructure and these activities that we are doing. We are going to host a business development workshop around energy sometime in the spring. It's actually on the next slide. We are also building these capabilities, for example, a space data lab at Vaasa University as well, and also looking into education and new projects and development activities with the companies as well. So the business development workshop, we already prototyped this within the waste management sector late last year, November, if I remember correctly. But the idea here is to attract a few bigger case companies to pitch kind of their challenges, what they are experiencing within their own industry for new products, new services, or within their own like company internal issues, and see how can the space-based data be utilized to create something new. And the idea is to invite a few of these case companies and then a set of maybe smaller startups or companies within IT or analytics or data science to create solution ideas for those challenges that the companies come and pitch. And indeed, it's like with co-creation methodology, quite in the center of the way of working with these events. So if anyone is interested, you can contact us. The preliminary date is April 28th. Also, we now have established a presence in the LinkedIn network as well. So if you want to come and keep up tabs with what we are doing and with our activities, please go and click the follow button there. You can find it with the Kvarken Space Center name. And of course, if there's something that you want to come and discuss directly with us, you can just send an email to me at my Muova or WAMK address. All right, so our next speaker will be Tero Vauraste from ICE.
Yes. Thank you, Jari. Okay, so if you have questions to Jari, you can talk with him and email him. And now we will go to our next presentation, which is Regional Director of Europe at ICE Limited, Tero Vauraste. Here, the floor is yours.
Thank you. Good morning, everyone. Greetings from ICE Espoo and internationally, as we currently have an international ownership basis, even though it's a Finnish origin company with its headquarters in Espoo. Today, we look into how the Earth observation data and more specifically synthetic aperture radar images can help the energy sector. I will first give you an overview of the company, about its history, our future endeavors, and then go to the specifics and different types of use cases, especially within the energy cluster. The company is established in 2015 and 16. The initial idea is from 2012, and the first satellite was launched in 2018. The first customers were brought in 2015 and 2016 as pilot cases, and actually the first pilots were conducted in the Bay of Bothnian area, so it's very nice to be here in this Bay of Bothnian area. We used Finnish icebreakers and had our first customer on the Aalto University airplane, which is actually more like a flying van, and nobody can really believe it flies, but the radar was installed into this flying van, and the first tests were conducted, and the first processing of the images were conducted in minus 25 degrees centigrade in a container in Oulu, so close to the Vaasa area. So it's great to see that there is this development taking place here. We already have more than 400 people working with us from more than 60 nationalities. Very recently, we secured our Series D, $136 million, where we have now secured funding of $300 million, which serves the launch plan for the next 2 or 3 years. And we consider ourselves as being the world leader in synthetic aperture radar miniaturization technology. We have launched 16 satellites to date, and the most recent launches have been conducted with SpaceX. And the most recent one was just 2 months ago with the Falcon 9 exolaunch. On this image you see the cubes with yellow on it. They are ICE images, and we use the rideshare model, which is economically very feasible. And we have a launch plan to more or less like double the size of the constellation within the next 2 or 3 years. So what about the SAR? As many of you are aware, the synthetic aperture radar data and images have the specialty of seeing through clouds and seeing through darkness. So on the right side of the image you see the SAR image, which gives you the geographical information of the surface, and on the left side you only see clouds with an optical data. European Space Agency is an important collaborator with us. We work on the Copernicus contributing mission and third-party mission with the European Space Agency and the European Commission, and just a few years back the current Director General of ESA, was saying that putting SAR on small sats is something nobody could have believed a couple of years ago. ESA has done it, and now we have competitors also, but we were the first there. So, what type of data we have available? On this image, you see the different image categories. So the largest one is called a scan, with frames of 100 times 100 kilometers. Then in the middle you see the strip, which is 50 times 30 kilometers. Then you have spot extended, which is 15 times 15 kilometers. And finally spot, which is 5 times 5 kilometers. And you can also extend these, especially the scan and strip. So you can use the satellite for a longer period of time for the capturing. So strip can be extended from 50 to 250 kilometers. And also scan can be extended from 100 times 100 kilometers up to 500 times 100 kilometers. And with the best resolutions we get with the spot images, you get down to 25 centimeters of resolution. So what does it give us? First of all, it gives a high revisit time. You recall the number of the satellites, 16 launched so far. Each of them is on polar orbits, going around the globe 15 times per day, i.e. 90 minutes on orbit. And the Earth rotates underneath. So when you make a calculation, you understand rapidly that you get a good visit time on any spot of the world, basically. So there are many imaging opportunities on whatever the spot is. Obviously, the closer you get to the poles, the better the frequency is, because the satellites go like this. But all of them are on polar orbits. So it's high sensitivity, good coverage, and also fast delivery. So we're able to deliver the images from the capture process to the client within a few hours from the capture. We are the first to provide daily coherent ground track repeat. So what does it mean? It means that we have a number of satellites on an orbit where you get an image from exactly the same spot on Earth within each 24 hours. And then you can make a comparison on the image and do interferometric analysis or change detection analysis and see what has appeared in the image, what has disappeared from the image, and what has stood in the image. And ESA is the first satellite company to provide such a service with synthetic aperture radar. So here is an example of this service. So this is the daily ground track repeat with amplitude data stack, which is acquired over the port of Rotterdam. On the bottom of the image, you see the change of the days. And then there you see what's appearing and what's disappearing in the image. What's happening with the containers, what's happening with the vessels, what's happening with the infrastructure, what's happening with the oil levels going up and down in the harbor. Another here, a more accurate image from the same spot, again with the amplitude data stack, seeing what's happening in there on the ground, what's happening with the piles, what's happening with the transportations, and so forth. Here an interesting one, again from the port of Rotterdam, and also helping the energy sector. You can see what's happening with the oil levels of the tanks in this series of images. And here, also the change detection gives you information with different colors. So on red, you see what has disappeared from the image, and with blue, you see what has appeared within the image. So this is, we call the daily information about the change with the change detection mechanism. So what does it mean here? This is the most advanced and precise model and method for the change detection. What it does, it compares the information of two coherent SAR acquisitions, and coherent means same time, same geographical position exactly, and it changes seeing the images which are in dark and in light which are not. So there you can see changes which are not visible to your eye, and we are the first one to provide this service, and here is an example of two separate images. Interferometry. For instance, we helped with the Fakradalsfjall volcano eruption, also with the La Palma volcano eruption, where you can see that the different colors in the image is showing the magnitude of the change in the area, for instance, what's happening on the formation on the ground. And for this, we use interferometric data, so it detects vertical changes and it gives you height information over there, and it also enables to create the so-called digital elevation model and analyzing of how the underground activities impact the soil, also including the constructions. The spot extended area, that's the largest very high resolution SAR imaging mode anyone has in the market currently. So here what you can do, you can detect objects and you can monitor changes. Here is an example of an image from Paris with this 15 times 15 kilometers. Again, the colors indicating the changes, what's happening in the area. Okay, let's then go for the use cases for the energy sector. What different types of opportunities we can see and how you can use Earth observation data and SAR images for this purpose and to support the energy sector. There's a lot of opportunities. Let's start with the renewable energy, which is one of the main topics of this conference. We have wind farms monitoring with ISI data, and this image is from a wind farm from Blyth, UK. And as you can see, what you can look in here is that how the positions of those are set, what's the situation within each of the system here. And also we can use this change detection and interferometry to see how those monitoring systems are working within there. And for instance, if there are fractures and things like that taking place in the systems. You can also use the SAR data on a vertical basis. So this is done from above, as you can see. This image is from above. But why don't you use the SAR data also from a horizontal basis? And as you can see, here is an opportunity of using an image for one particular windmill in here. Power lines monitoring, another important area in here. So this image is from Germany, and this is like a combination of two ISI images. We also have an opportunity of using, we call it so-called tip and cue. So you first use the larger image, and if you detect something which is of high interest to you, then you go down to a smaller image, for instance, with spot or spot extended. And this is for the power lines in here. And you can see what types of activities are happening within the power lines in terms of security and safety. If there are storms coming, if there is different types of activity which might endanger your power lines, you can detect the activities with the help of SAR data. Here, another example, which is hydroelectric power plant monitoring. So in the middle of the image, as you can see, we do have a hydroelectric power plant. And for this, there are different types of opportunities again. And for instance, if there is a dam, you can detect changes in your dam. You can also use interferometric data of making sure that the structures of the dam are being safe. There's been different types of big disasters in types of dam failures. For instance, we recall an event a few years back in Uzbekistan. So these types of opportunities can be helped with the help of SAR data, that you detect the changes which are coming and you are able to have your activities taking place before the worst comes to worst. Another example, which is from Poland, and here you see that here's a pumped storage hydroelectric plant. You can survey what's happening within the basin area over there. You can also detect the height of the water and make analysis about the amount of the water over there. And this is a spotlight mode, 5 times 5 kilometers with the best resolution. Pipeline monitoring. This is from Canada. This is with the Portland-Montreal pipeline area, where you can see that we can support. The SAR data doesn't see underground, so if we do have something which is happening underground, that you don't see. But if you see something that is happening underground and affects the soil, that is something we can also detect with ISI data and SAR images. 2 years ago, there was a severe dam failure in Michigan. And ISI helped with our data to support the authorities to make the activities on that. So flood monitoring is an important area of our analysis. We provide 3 types of services. We provide the customers with SAR data, the 4 different types of images, but also with analytics, and especially for different types of natural disasters and flooding. So for the flooding, we use also different types of other information and use them as a layer. So the SAR data is only one part of the information, where you also use geographical information and other sources to provide the customer with an understanding of the development of the flood. And this is something which we did in Michigan. For that, we work with authorities. We also work a lot with the insurance companies internationally on this one. So here you see there is the Dow plant in Midland and the overtopping river barrier here. This took place in Midland area. And here is an understanding of the flood extent, where you can see the different types of layers used to make an understanding of the depth of the water and with the geographical information about the area in question. Mining activity monitoring, another example. So here we have a brown coal open mine and a power plant. So we can have a look what's happening with the coal area, how the different types of piles are developing, and what's the expectation of the magnitude of the material. This is from Chile, and as you can see, here is a mining area, another example of opportunities. And as you can see, it's very, very accurate. You can even see vehicles in this image. And this is again spotlight. Commodity shipment monitoring to help, for instance, with oil tanks, containers, stockpiles, and this is again from the port of Rotterdam area. To help in oil spill. So, for instance, this image is from Siberia, where you can see that there are dark portions in the water. They suggest that there is oil. So you can also make an estimate about how large the area of oil is in question. Again here, another type of opportunity or an image. This is from Aberdeen, UK, from the North Sea area, and again an oil spill which has been detected. So, what does it give you? It gives you persistent monitoring, frequent revisit, rapid delivery, very, very good delivery times. Within a couple of hours, the customer is able to get the image. And as you can see, we have been able to reduce the average time from downlink to delivery. So the satellite gets the information of the customer need, so we call it the uplink. Then it acquires the data, and then the data is being downlinked to a ground station. From the ground station, it's being put to a cloud where it's being processed. Then it's brought to ISI server, and from ISI server to customer server. And this all is done in less than just a couple of hours. And this is done with the help of global ground station network, where the demonstrated downlink time has been as low as 5 minutes with the special arrangements. We also can do the direct downlinking direct to the customers, and everything is encrypted. We do have our images available free of charge, so please make use of those. Go to isi.com and datasets. You're able to download the data from there and make use of the best SAR images in the world provided by a company origined in Finland. Happy to have a discussion with you afterwards and in the panel. Thank you very much for your time.
Thank you, Tero. Very interesting. I was thinking we would allow one question from the audience, sure, if we have any questions. Any questions? You have the mic, yes.
So you mentioned that ISI is not just collecting and delivering data, but as well analytic services.
Yes.
Do you as well deliver data for, or plan to deliver the data for other companies that, for example, specialize on analytic services only? What is kind of the business model behind your data distribution?
Very good question, because actually when you look into the market for analyzed data is much larger compared to just pro SAR data. And we do have collaboration with several analytics companies. We provide our data to them, and they move on with the derivatives for the end users. So we have two business models in the SAR data. So it's either direct to the customers, pure SAR data, but also different types of analytics tools are used with several partners. And sometimes they are brought in by us when we understand the customer need, or a customer can also suggest. And there is also a model where we provide our data for the analytics companies, and they move on then with their market. For instance, with the mining industry.
Okay, thank you very much. Excellent presentation. So many opportunities for the energy sector with this unique data. Now we will move forward to our next presentation that we will have online. We will have Eduard Escalona Sorita, Space Downstream Market Officer at the EU Agency for the Space Program in Prague. And I'm hoping we have Eduard online.
Yes, I can see myself, so I guess you can see me as well.
Yes, we can see you. Good
Excellent.
Morning.
Good morning from Prague. Thank you very much for inviting me to this session. I'm very happy to at least be able to share with you what we do at USPA online. Hopefully next time I can join you as well physically.
Yes. Okay. So with the slide sharing, do you have? Yes, you have the control there. So please,
do I have the control or just?
Okay, so
no,
maybe you can just tell me, maybe I have the control.
Exactly.
Just tell me when
Yes.
when to change. Yes, please go
Okay.
ahead.
So yeah, I want to explain to you a little bit what we do at USPA, or who we are as well, and what are the benefits that the use-based technologies can offer in the energy and raw material sector as well. So let me start with an introduction of USPA and say a few words about who we are and what we do. USPA stands as a European Union agency for the space program. We are headquartered in Prague, as you mentioned, the Czech Republic, but we have several offices and operation centers across Europe as well for monitoring signals of Galileo and for security. Officially, USPA was born last year with the new space regulation, but also it's a kind of a transition from a previous agency that was GSA. It was the European GNSS agency in charge of Galileo. So now we have expanded our role and responsibilities, and basically the new responsibilities are to implement the whole EU space program and to provide reliable, safe, secure services, space-related services, and also look at the exploitation of the services, looking at the socioeconomic benefits for the European society and the European businesses. And the good or new thing is that for the first time we have under the same umbrella all the different EU space components and activities. And one of the key responsibilities that we have in the department that I'm working in, this market development department, is the exploitation and downstream of the market development of their services. So next slide, please. So just very few words on the two main services that I will focus on, that are the GNSS, Galileo, and the Earth observation one. So Galileo, it's the European global navigation system, as you might know, and it contributes to the existing other constellations of GPS or GLONASS, and thanks to this new constellation, we can increase the signal availability and also the accuracy of positioning for users. But also Galileo is actually the most advanced GNSS globally. Actually, it will be the first system that will provide a high accuracy service, the HAS service, globally and free of charge, which will benefit really a lot of market segments and industries. And also will be the first one to introduce an increased signal robustness thanks to authentication services. And this is to prevent spoofing or fake signals that would give you fake locations. So these are very exciting services that will come in the near future. So then we also have the important Earth observation program of the European Union, that is Copernicus, that you all know. Which the main characteristic, of course, is that it provides open and free data about the Earth and its environment, and globally, and free to absolutely everyone. And what is important to mention here, and is complementary also to the presentation that we have seen by Tero before, is that it's not only about the satellites, about the Sentinel missions, but it also, Copernicus has two other components, which we call the in situ component and the Copernicus services. The in situ component is basically composed of a myriad of sensors distributed worldwide and providing complementary data to the ones gathered by the satellites. And then we have the Copernicus services that are getting all this data and are providing, let's say, processed and analysis-ready data that are basically organized in different thematic areas. So, for example, we have atmosphere monitoring, marine-related services, land monitoring, climate change, security, and emergency management. And Copernicus is the number one world provider of space data and information. It provides more than 20 terabytes per day of information. So this information, the usefulness is that it's current, but it's also historical. So you can access information completely free of charge about historical data. So you can do analysis of what has happened in the past, and of course what forecast of what can happen in the future. So focusing on the energy sector, so we know that both Galileo and Copernicus can provide valuable inputs to different stages of the energy value chain. And here, I will particularize it to the contribution to renewable energies. And of course, I'm talking about the three most well-known, biggest with the biggest share, that are solar, hydropower, and wind energy. But also there are other alternative or more innovative or new energy sources that still have, let's say, untapped potential, like offshore energy, different types of offshore energy, and biomass, that can also play a key role in the future. So, next slide. Now I'm going to go through. We will not go too much into detail, but let me go quickly through some examples. So specifically showing what kind of data can Copernicus provide for these different sectors, and how can it be useful. So for example, for solar photovoltaic production, the atmospheric and climate products of Copernicus can help select the optimal site locations. So optimally select what are the best locations to locate solar power plants, can estimate the potential production or support predictive maintenance of through different types of analysis of solar radiation data, or other atmospheric analysis and forecasts. And these are products that are already offered by the atmosphere monitoring service or the climate change service. Next one. Similarly, for wind energy, for wind farms and wind power production, Copernicus-based data can also be used. For example, land cover data, digital elevation models, similarly to what Tero mentioned. There is information, for example, about the climate variability, and all these can similarly to the solar, can help you, or can help producers of wind farms select what is the most suitable sites for locating these wind farms, estimate future predictions of the energy, and as I said, we have also information about the past, the present, and future forecast of wind information. So this can really provide a lot of information useful for estimating the energy production that one power plant can produce. For hydropower as well, and here in this case, Copernicus can help. Copernicus data can help to predict volumes, water availability in dams, different temporal distribution of river flows, for example, It can analyze the dynamic extension and the depth of snow cover, which is also important information because it would translate in water flow from snow melt. So you can make predictions and make and you can translate that into a better management of hydroelectric plant production and for example on price forecasting of the energy. And in the next slide you can see the other renewable energy sources that are not so well known, but also have enormous potential to generate big amounts of energy if they are exploited and leveraged correctly. So the most notable ones are offshore energy production, and this can be based on a different number of systems, for example, based on tidal energy, on winds, of course, similarly to the ones on land. But even some innovative energy production based on salinity gradients and energy produced of plant-based fuels, so known as the biomass energy. So different Copernicus services and products can help monitor, for example, sea currents, sea winds, but also can trace the health and status of crops, vegetations, mapping different type of lands, for example, that are not suitable for food. These are called marginal, underutilized, and contaminated lands. And all this can support the monitoring of biomass production. So all this data can support all these also innovative ways of producing energy. But not only Earth observation, because the title was about synergies. So what I want to mention is that also GNSS data for navigation, for positioning, can help the industrial sector. And here I want to show you only some few examples. So, for example, GNSS can play a role in of course, in the surveying and precise location of the power plants, of the infrastructure, of the different, for example, windmills. But also, it's very useful in performing a very accurate maintenance and monitoring of these infrastructures. For example, using drones, managing the position of the drones to monitor how clean are the solar panels, to estimate the energy production. And also, it's important an important case is in smart grids, where the use of GNSS giving a precise time and synchronization reference for the energy distribution for smart grids. Also as backup, for example, in case of outages, it's very important, and I think there is a talk specifically talking about this later on. And I also wanted to spend a few words on and show some examples in the raw materials or mining sector, because it's the sector that we put together is under my responsibility and in USPA, but it's also related to the energy production, for example, in the case of coal extraction. In this sector, and as many others, is experiencing a big green and digital transformation, of course, to increase the efficiency and to reduce the environmental footprint that mining creates, and space data can contribute to it. So we can see in the next couple of slides as some examples. This one is about Earth observation. So Copernicus here can provide a continuous flow of information for all the phases of the mining processes, and in particular, for example, for site. Still with the previous slide, please, for site selection, detection of mining sites, monitoring of the environmental impact during extraction, closure, and aftercare phases, but also for monitoring the stability of constructions. And yes, the next slide shows the applicability of GNSS. And here the synergies are even more clear, because GNSS is already being extensively used for the mining for example, for machine guidance and control, for mine surveying and mapping, but it's now also increasingly being used in new emergence with emergence of autonomous equipment and new applications like augmented reality, the position of wearables and IoT devices, and so on and so forth. So there are lots of uses of space data, and in this case of AO and GNSS also in the raw material sector. So now my last couple of slides is I just quickly want to inform you that we had recently published in January the first USPA Earth Observation and GNSS market report, when you can see all the applicability of the data in along all the different market sectors that where this data can be useful. Here I have just circled the energy and raw material sector, which is the most relevant for you. You can find lots of information there, so I suggest you to, I encourage you to download the report. It's free of charge, of course, and this is a report that is leveraging from the previous one that we had on GNSS, and it's very useful. We have received very positive feedback for investors, for people working in all these sectors. And finally, in the last slide, just to mention that as an agency, we have several initiatives for foster innovation to help the creation of companies, the creation of innovative ideas using this space data. And here just the 3 programs we have for R&D, but also for entrepreneurship, which are Horizon Europe, with the different calls, fundamental elements for the creation of new receivers implementing GNSS, but also the new Cassini initiative, in which we want to foster the creation of startups and help them to grow. So you can find all this information in the USPA website. When are these calls and when are they published? And of course, we have dedicated workshops and webinars and info sessions for all of this. So that's all I wanted to say. So thank you very much for listening.
Thank you. We have time for one question from the audience, if there would be any. There's a question.
Hello, my name is Kendall Rutledge. Thank you for your presentation. We've had recently the opportunity to work with Forestry TEP, and I'm wondering the thematic exploitation platforms. Are you knowing about these, and are they offering an opportunity for new types of business opportunities, business connections?
So I'm not sure what are you referring to as the thematic exploitation platforms. Is with regards to Copernicus you're talking about?
Yes, they are companies connecting to these processes? Are they designed for this purpose to sort of evolve in time and to have new applications built on them? Is that what's possible?
Okay, so this is a new initiative by the European Commission with the help of the entrusted entities. So there are different thematic exploitation platforms. There is one, for example, on health. There are others being created. And the intention as well is to involve industry in these platforms. As you know, one of the main roles of Copernicus till now has been the exploitation of this data for what they call core users or for more policy-driven initiatives. And now the role of USPA is to leverage the use of Copernicus also for commercial users, for the industrial sectors. And this is what we are here for. And our intention is to also use these exploitation platforms, exploitation hubs for involving the industry. And but this is still in early stages, and we have to see how to do that. Then we also have at USPA one initiative that's called the User Consultation Platform. The first one that will include Earth observation fully fledged will be in October this year, and we will announce the developments and the dates later on. So just keep informed, because one of the sessions will be on the energy and raw material sector. So, and here of course we want to fully involve the industry, because it's an important place where we discuss about trends, about requirements from the industry. So the industry definitely will be involved.
Great. Thank you so much, Edward. And it was great to have you here in Energy Week, and the EUSPA contribution to the energy industry is tremendous. Thank you. Then we will move forward in our program, focusing still now on natural energy supplies, and we have Development Manager Mikko Stralendorf from the Finnish Meteorological Institute. The floor is yours.
Thank you very much, and good day to you all. So, I will actually go on from what Eduardo was bringing in with more practical examples. But first, just to quickly say, I'm actually coming from the Arctic Space Center, so the Tähtälä place, and in Helsinki from the Finnish Met Institute. And we very much welcome also the Kvarken Space Center, because more space centers in Finland is all good. So well, let's get into this business, and I will just concentrate on examples from wind, solar, and hydro. So just to see how is space enabling and monitoring of these natural energy supplies. And then I think the most important question is, where are we at the moment for being able to utilize these informations, and what is more possible? So starting off from the fact that we do have, and this is now not, for example, ICE-I satellites, but these are government-owned, mostly operational satellites that the World Meteorological Organization is using for all kinds of day-to-day operations of weather forecasting models and many others. And they are generally on 2 different orbits when you look at the numbers. So 26 satellites are in geostationary orbit. That means above the equator. There's a satellite that can see, let's say, half disk of the Earth. Then we have these low Earth orbit satellites that are rotating around the globe, just like, for example, ICE-I satellites. Usually something like 90 minutes is the time that they go around. We have some other exotic ones. We are also looking at the sun and the moon. Let's not get too deep into them. But what I think is very important, that especially from Europe, with some examples, and the example from the US, most of these things are getting to be more and more open and free. So all this information is available to anyone for using for anything. And especially the European, also the meteorological organizations have just started to open up their data policies and share better what they have in their things. And this is very much because of the EU Copernicus program. I'm very happy to be the Finnish delegate at the European Space Copernicus Committee. So in a way, this is my work. I love that. So, but here are examples now for the wind. So what kind of wind observations do we have from space? Something called a scatterometer. I will not go into details of this in a sense of how is it done. But we do see that there are, for example, at the moment, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 satellites, or the ISS, or the International Space Station is also one of them. So they are monitoring this on a kind of continuous basis every day. These are operational at the moment. And this is an image what they can do. So they have really kind of wind direction and speed measurements from sea surface. And I put here on the right upper top also to see what the resolution is. So this is the METOP satellites, so the European ones. We have B and C up there doing this, so that is combined in the image. And you can see that this is the granularity of how can we see wind observations from the sea side. And we can drill into one place and look at it. And the day before yesterday, it was 6 meters and the direction from somewhere pretty much south. No, not from the north. So just an example of what can be done. And how do we apply this, for example? So Korsnäs, not far from here, there's a wind park being planned. And so we from the Finnish Met Institute were actually asked to make some wind statistics from those years. And I used now a different satellite on the scatterometers. So the Sentinel-1 satellite has a 1 kilometer product. And well, they have been actually flying really earlier than 2018 already, but this product has been available from 2017 somewhere, so we started to take the full years. And that is just the example that we can, for the corner points of this wind park, make these called wind roses. So from which direction, how often do you have which kind of strength of wind, so that they can take this in account with planning the park. And then another thing that the Copernicus program is producing is the ERA5, so a reanalysis product where all different satellite material and in situ observations are put into a modeling system to kind of make all those observations kind of fit together and then have the most kind of concise information about variables of the atmosphere and also a lot of the surface. And from there you can, for example, take the 150 meter height mean wind speeds for different direction in this place. And you can see, of course, that because the coastline is not too far to the east, so of course the easterly winds are not so strong. But let's go then to the solar energy, and I think here, can we start this video? How do I do that? Here, I guess, or someone from the operating room. There's a video, so if you can put it on, please do, because I wanted to demonstrate here that the solar energy in a business is kind of what is needed anyway for a lot of satellite observations. That's why most of these satellites actually fly in a sun-synchronous orbit, meaning that they need the reflection of the light. So yes, please come and put it on, because I can't remember where it happens. Anyway, this is the idea that Sentinel-3, let's say, is one of those Copernicus program satellites. We have 2 of them flying, and what I would have shown here in a nice animation is that you get, like in one day, you get all of the Earth almost covered, but it is then not so many observations per day. So for solar energy production, that might not be enough. So we actually then want to kind of have something like this. And now it would be really nice to get that play button done. Anyway, so the geostationary orbits are of course looking at the same place, and they get every 15 minutes, for example, this full disk image. And what would have been nice here is that you can see that because the sunlight is needed for this product, the left side now in this image is empty. It would have been filled with this beautiful animation, so I hope everybody can visit these slides later and have fun with them. But here, the point is that this is something that then is very much used by solar production to monitor what is it that they should have as production, because they can actually get into the details of what solar power is coming in, because the clouds are visible, so we know how much should come down. It's always combination of satellite data, some kind of modeling post-processing to get to the thing. Another product that is in the same slide, that's why there's also some blue precipitation informations around there. A lot of the products are also based on infrared information, so not needing the sunlight. So there's lots more, but I think for the solar panel example, do I have to click now many times? Oh, no, it just didn't react immediately. Let's get back. So, one more. This one I wanted to show. So, just an example of what you can then get. So these data sets we have from February 2004 onwards. So I actually downloaded, so all of these kind of examples I just took yesterday coming here with the train. So this data is really accessible easily. And here, just an example that you can plot. This is just last year and then the beginning of this year of how much, let's say, solar power would have come down for Vaasa. And yeah, I think this shows nicely that it's still, even for a place like up north in Finland, not an impossible idea across all of the year to actually get solar energy as well. So just think about it. And this data you can get in 1 minute resolution. I took here only the 1 hourly data sets. And then this is quite a lot used in Central Europe. This is part of the Copernicus program. But there is also some extra work that Armines, so colleagues in France, are doing to get even small forecasts of this. That helps best to then regulate and monitor the solar production. But let's get then to the last example, hydropower. And I think here the plane here is actually the one that Tero was referring to, this wonderful van from Aalto University, just to have some connection in these slides. But how this was done is that we have these passive and active microwave products and optical to try to see where do we have snow. And snow is really the biggest thing for a lot of hydropower production, because when does it melt? How much do you have there? Those are questions that need to be kind of known beforehand before you start kind of running off that water through the dams. And this is why we have quite a substantial service built up here. And it's really based on passive microwave for snow water equivalent mostly, but a little bit also on the fractional snow cover. The Finnish Met Institute is involved in this consortium that is doing actually for Copernicus Global Land Service a 5-kilometer Northern Hemisphere snow water equivalent. And yeah, it has been running since 2017. I think there's just an upgrade coming up soon, but in essence, that is data that is also available easily. But let's get to the point where this is needed. So, for example, Kemijoki Basin, so it's 55 to even 70% of all the water in the whole year that they can kind of flow down is actually coming in snow. So if they can't know how much of it is there and in which places exactly, because they are running these many dams you see in the picture here, so where does it come from, at what point, they need to know that. And that's why they are very much interested in getting this kind of snow information from satellites, but then to make it useful, we do need a hydrological forecasting system. And I think this is an example for many other products as well, that there is the observations from space, but usually need some kind of post-processing modeling system to then make it the real end-user product. Yeah, let's not go too much into details, but hops.fmi.fi, it's actually a site that you can even visit and just check out. Here the animations work because they are GIF, so that was my mistake, I guess. But here you can see that we have lots of different data sets for them to know about soil moisture, soil temperatures, then the snow itself. And we do forecasts forward, even like seasonal forecasts for 200 days ahead. But all of that information is put into a system that then Kemijoki Oy, and while operating the different dams, can use, look into, and really just like fill their days with looking at nice data. And then the other products from Copernicus, for example, we also know that the Swedish Meteorological and Hydrological Institute in their hydrological services are using these data sets. They are used a lot in weather forecasting, geotechnical engineering in mountain areas. So applications, there are many, but I would say in a conclusion slide that we are still just at the beginning of this, especially that so much data is now fully and freely available for anywhere in the globe. I think that the point is here that not even a large part of these things are done yet. So I think there's a lot to be done, and why this is not yet ready is that you usually need some statistics and post-processing, and satellites have to be up there for a while to get that time series long enough to get it done. But we are now at this point that, and especially when we have these second generation artificial intelligence machine learning systems, that they are kind of now starting to churn up. So welcome to this business, and yeah, thank you very much for having me.
Thank you, Mikko. Do we have a quick question from the audience?
I'm happy without one, so don't worry.
What about your opinion? What do you think is the most prominent application now in the renewable sector? We will address this in the panel, but based on what you have been working on at the Finnish Meteorological Institute.
Well, we are so involved in this hydrological system and snow kind of information that for us that's clearly there. But I'm quite sure that, let's say, when we have to do this green transition, then, and especially in Finland, we have so many opportunities, the wind parks out there in these shallow waters, that's probably for us in the next years the biggest thing to do more. And then solar power is, at least in Europe, actually a very kind of, it has grown already a lot. So there's again something that in Finland, so I think that these new opportunities are more interesting for me to at least to follow.
Okay, thank you. Let's continue in the panel, you as well.
Thank you.
Then we will move forward in our program, and then I would like to invite to stage Dr. Ilona Söhting, CEO of Analytics Spica, and we will focus on situational awareness for energy infrastructure projects.
Yes, thank you very much. And yes, thank you for brilliant introduction of the data done by the previous speakers. And so, towards ultimate situational awareness. As actually mentioned by the previous speakers before, there is a wealth of data emerging. Yes, we are pretty much starting to drown in data. So this is now the era where we need to start to think as how do we connect this data together to get the best actionable insights. And I put an emphasis on actionable insights. So, well, the obvious thing is merging satellite data and in situ observations, which is actually already done. And if you ask why, oh, in a nutshell, basically we have all data systems have advantages and disadvantages. So like, for example, for the satellite data, the main advantages are obviously the global spatial coverage, the amazing consistency usually that can be offered, and broad spectral coverage. As you have seen, they are just simply so many detectors. You know, most of this data collected is actually way outside of what human eye, you know, can perceive. And well, no boots on the ground needed to get the insights. But there are disadvantages too. There is a limited temporal resolution. Even so, we are excited about the revisits in, you know, space of hours for higher resolution things and minutes, but then we have extremely low resolutions for many monitoring applications beyond kind of weather and kind of global movement applications not really suitable. We cannot actually use it to, for example, monitor changes on sub-hour level, minutes level, and so on. So we still need other means. Yes, obviously the bigger the area, usually the smaller the spatial resolution. So basically how much information actually the sensor can grab, you know, how many channels can you have, be it pixels or other beam channels to gather information. And yes, in many places this data is very heavily weather dependent. And so we have seen nice example of SAR data being not, but again, this is a narrow spectral band for only certain applications. Very limited penetration of structures, pretty much approaching zero, but there might be some remedies coming up, particularly for the GNSS applications and so on to improve. So, well, in situ measurements, advantages, well, obviously unprecedented diversity. There are thousands and thousands of sensors out there. You can basically choose and match what you need. Accessibility. Well, not only for repairs, but basically, have you done the wrong choice the first time, you still have a chance to quickly go there and replace. Continuous temporal coverage. So this is nowadays, particularly with good communication systems, you know, we can have a sub-second event granularity, temporal granularity of data collected by in situ sensors. High precision events, so I do have warning here. High precision is really usually for well-maintained measurement systems, which is often not the case. Well calibrated and well-maintained. And with now miniaturization of sensors, actually many can be embedded in the materials, asset material, which is really, really great. But there are disadvantages. Well, first of all, you need a physical access. And sometimes this sounds trivial. Well, we are just building a plant. Yes, we are putting some of our gear down there. Well, it still does not mean that you will be allowed to have some kind of auxiliary system or measurement systems installed, because it's actually not your plant. So they are challenges. Very tiny spatial coverage, basically the area of the sensor itself. If you have a weather station, well, you could assume that this is the surrounding a few kilometers around it that gives like relevance to the measurements. And as I mentioned actually before, which could be advantage and disadvantage, accuracy subject of calibration and maintenance. This is something that is so often forgotten, you know. A sensor dumped on a location some years ago and nobody looks at it, please, you know, do not assume that this data is anyway accurate. So, getting the best of all worlds. And this is something that it's now becoming very excited. So I put here, don't get scared, this data and information fusion ladder. It has been established decades ago, and yes, sometimes we do question if it's still applicable. So I added on the right-hand side a little bit of the modern interpretation to it. So we have the basic levels where we have really the signal processing base interpretation. So it's a pixel level, the kind of electric impulse level processing, and then extraction of a signal of detection. But this is very static, and it's usually done by well-established signal processing system, which sometimes don't even have to be particularly smart. Interesting area, it's starting at level 2 and 3, and I think this is now the area that it's starting really to boom. Because with application not just of advanced statistical method, but now machine learning and deep learning emerging very fast too, we can establish that actual situation assessment. It is basically by contextualization of the information. So by having insights from different sensors, being from up and the ground, we can put information into context, and not only into the context of now, but by training models, we can actually make the prediction. So what will be the consequence of this situation in the near future? This is really now heavily going towards machine learning. As I said, they are still very well-established statistical methods, but I would still, in many cases now as well, deep learning and so on, it's starting to make a massive impact on this area. Then we have a process control, which is basically the old level 4 process refinement. So resource management, adaptive control, and so be it done manually by humans still in many places. You know, temperatures go down, somebody puts the lever, you know, gets the machine working maybe in a different setup. But a lot of it is now automation. But some underestimated layer, which I think as well is the area that must grow and is growing, is the UI and UX. As mentioned before, and as is shown in this by the speakers beforehand, you know, there is a massive amounts of data and information emerging. But still on the end of the ladder, we have the human being making the final decision. So how we do represent the data can actually bias decision making. So this is actually really, really important aspect of actually research and now kind of business exploitation, how to collect all these insights from these different streams after we have done all the signal processing, machine learning, to provide it in so-called actionable manner. That human being, and this human being should not be expected to be data expert, because this might be an engineering expert, a business expert, etc., to make the best possible decision from the information that is available. And this is really where data science meets psychology nowadays. So, and some could see it as a computer to human delegation. Actually, at Analytics Spiker, that's the company I have founded, we started even looking with some robotics companies, actually how this UX UI layer would need to be designed that a robot, for example, inspection and maintenance robot on an energy asset, would make same decision as a human being presented with information. They are often now at the level go, no go. You know, are we actually starting to work or not? But so the human or computer to human delegation is moving downwards, so the computer is really taking over more and more steps. So something that we should not forget. Just a quick nutshell. You know, for levels 2 and 3, when we all talk about this machine learning statistical model, this is a really natural, very simplified view of it. Basically, we do have locations where we have all this global data from the satellite, but as well a very nice measurements, for example, proper measurement, well-maintained measurement stations, and so on. We collect the data, and then we can derive models that allow us to pretty much predict the situation or reproduce the situation on, just from, for example, global data. Having those models mean that we are acquiring like a global transparency that can be used in planning, construction, and operation of energy assets, because it enables us in locations where we do not have the ground truth, still from the model prediction acquire very good representation of the situation on the ground based solely on satellite data on remote sensing data. So this is a very simplified model. People who have done modeling and so know that in this model box, there could be quite a lot going on. Another aspect, sometimes a little bit dropping under the table when we talk about information fusion, data fusion for actionable insights, is the adding of human data activity. And I don't mean data about human activity on the globe, because often this activity is now so profound that it can be easily seen from space, but actually data put by humans into the system. And obviously each company sits on terabytes nowadays of different accounting data types in, but I'm not talking about that. This is even the administrative boundaries and limits. And they actually are never visible from space or on the ground, but they pose a significant constraint on planning, on actual construction, execution, and operation of any energy assets. So this is something that as well needs to be put into the mixture. So there we are starting to arrive on quite a complex view. You know, there is so much information going in. So it is where it's kind of our dedication, you know, being very proficient with modeling and you know, data reduction analysis. Now, how can we push the boundaries to make the data really, really actionable? How can we be sure that people can make really the best possible decisions on the data without spending months and months on it? In certain applications, particularly on energy assets that might already operate or during construction, people are expected to make decisions within seconds in changing conditions. So how can data be represented? And actually this data collection and representation is something that as well struck us in our recent project. Actually, we just finished a feasibility study for our new product, which is at PACE, the Project Awareness and Collaboration Environment, that it's developed under the program of and funded by the European Space Agency. And I would really like to thank our collaborators from University of Vaasa and the experts in service design from Design Center Muova in Vamkir, who were helping with that. And you know, we talked to so many companies in the value chain for construction decommissioning of energy asset in the offshore setting. So it's a remote location setting. And there is this prevailing, you know, pains and challenges. So the project teams are collecting information again and again and again. They spend really, really hours on it, and they share it. And despite, I mean, these people are professionals, all the due diligence still, there will be team members not having the right information or having old information or never even knowing that certain information is there, so they will never ask for it. So, and then the deployment operation of crews, we sometimes forget they are harsh conditions, they are remote places, not simply getting into the car and driving to office. Yes, so there is a massive preparation of deployment. This training and pre-deployment often requires a lot of travel to site. Obviously, in the era of CO2 reductions and so on, this is not just a financial burden, risk to people, because each of these trips is actually a risk, a valid risk to human life, but as well a pollution. You know, it's a major exercise flying out those crews to those assets. But there is still lack of really interactive tools that, you know, would allow us to meet in virtual spaces and conduct this training. Obviously with virtual reality sets, and so it's emerging, but we need to remember as well that value chains consist of different players. Yeah? So what is for us given, just getting, you know, VR set, no problem. For some other subcontracting companies and so, this is not. And they might be lacking the technical and financial basis to utilize such technologies. So there is as well a lot of scope for improvement. So basically what I'm trying as well to say that any products that serve data to customers really need to start to concentrate on provision of key asset and location data in one place. This distributed collections and emailing around, it's really very destructive. Data must be accessible for years to come. Basically, those assets, the projects that have been constructed assets go over 10 years or so. This data must be still there. It must be as well as transferable with the asset. So data is nowadays part of the asset. So it must be in the forms that can be easily transferred when the asset changes hands. And obviously, project reproducibility, event logs and so on. So yes, global data, and as we've been shown, particularly from the EU and US, there's this amazing movement to give us a lot of free data, and that just transforms the energy business. We can easily identify and quantify new markets. We can look at the impact of global warming and change of land use on the viability of the current markets, and optimal technology choices already at the early stages of the project, actually at the stage of quotation, basically. Based on remote sensing data, good estimates can be made. And yes, rich context and validation of in-situ IoT data. So, if you have a temperature sensor, you have only one on site, you might want to question it and compare it what, for example, the Copernicus data is saying, and be sure that this is all still working properly. Thank you so much.
Thank you so much, Ilona. Unfortunately, we don't have time now for questions. We need to move on to our last presentation in the seminar section before we move on to the panel. And now I would like to invite to stage Jari-Pekka Kankaanpää from the Distribution Solutions at ABB, talking about GNSS in power grids. Yeah.
Really goes to show how engineers work. Sorry for that. Real bad, how should I say, intro for me, but yeah. So I'm here to represent you how GNSS is utilized in power grid applications. This is kind of a broad subject, so I'm real sorry if the structure of this presentation may seem a bit confusing. This presentation contains a brief introduction to why GNSS is utilized in power grid applications, few examples of different devices utilizing the signals, and then a few example applications. So, power grids may seem a bit odd place to utilize GNSS signals, as power grid equipments are often firmly installed in known locations. However, many modern power grid applications often require precise timing information between different devices. GNSS addresses this by providing accurate time reference for the systems. GNSS can provide time reference for individual devices for dedicated synchronization services. Timing services are essential for implementation of certain applications like power grid protection schemes, distributed power generation, and smart grids. Currently, most of the power system protection schemes are designed around individual components. However, the grids are getting more complicated and system-wide disturbances are becoming a frequent problem. Major disturbances require coordinated protection and control to minimize the impact to the system. Here are a few examples of devices which can use the time reference, protection and control relays, phasor measurement units, merging units, and traveling wave data acquisition devices. Protection and control relays are a prime example of individual components which may utilize these signals. They are intelligent electronic devices which can isolate faulty sections of power grid from rest of the grid. Line differential protection schemes implemented with relays often rely on this time reference. Phasor measurement units are devices used for power grid health determination. They measure both the magnitude and phase angle of the sine waves in electricity. And GPS receivers are usually an integral part of PMU and make the precise sampling possible. Merging units, on the other hand, collect the sampled values from electronic and current transformers and transmit the data to secondary devices. Merging unit is the applied foundation for electronic transformers in today's or futures intelligent substations. They must provide stable samples in relation to accurate timestamps. Traveling data acquisition devices are responsible for capturing traveling wave information for analysis purposes, and faults occurring in transmission lines generate these traveling wave signals. Precise timing information is a requirement for accurate location of faults, and when triggered, the acquired data is sent to a master station in the network for the analysis. So, one case of applications of GNSS in power grids is wide area measurement systems which rely on the phasor measurement units. They require phasor and frequency information from multiple devices, major disturbances, and require coordinated protection and control to minimize the impacts to the system. Since actions based on conditions and events are not always enough to control the power system stability, it is possible to utilize wide area monitoring and protection and control for adaptive detection and control strategies. Wide area measurement systems complement data acquisition functions of protection relays, fault recorders, and SCADA systems. The picture on the right displays an example of an VAMS. The phasor and frequency information is collected from multiple points in the grid with phasor measurement units connected to GNSS receivers. And they are used for wide area protection and control. The modern VAMS allows advanced protection and control strategies. They can be utilized through, they can be applied to, these can be applied through implementation of new analytical tools. The objective of VAMS is to provide real-time monitoring capabilities and to improve the situational awareness of the grid interconnection and provide enhanced view of grid conditions. This facilitates confident decision-making for ensuring the grid stability. Line current differential protection can consist of multiple microprocessor-based relays operating independently, exchanging the information. Each relay samples its input currents and transmits the local current data to another one. The current transformer provides the local current sample for the relays. This sample is appended with timestamps and transmitted to the remote relay. As full set of current data has been collected from local and remote sources, a differential trip equation is executed for determining the potential fault location. Here you can see a quite simple overview of a line differential protection scheme. Current transformers seen on the top collect the current data from the transmission line and deliver it to the relays. When the full set of the current data has been collected, it is sent to remote relay, which then triggers the protection if it seems necessary. Another application is sampled values. Sampled values are digitized instantaneous values of power system quantities like voltage and current samples. The process bus architecture specified in the standard was proposed for reducing the complexity of copper wiring in substation automated systems, and accurate time synchronization is an requirement for sampled values. Merging units or collect or sample the outputs from current and voltage transformers. The collected data is then transmitted forward in a standardized form to another devices. Traveling wave fault location is an important application as well for resilient smart grids, providing better guarantees for safe operation. Accurate fault location provides great value for power transmission asset owners and operators. The fault location systems are based on high accuracy clock synchronization, and the precise positioning of the whole network can be achieved by recording the arrival time of the traveling wave in each substation. The picture on the right displays a wide area traveling wave fault location system located in China. The fault located between substations S1 and S2 can be seen displayed on in the red spot. The other substations connected near to the fault also will, how should I say, make sure that the information is correct. Oh, so that was it.
Thank you. Are there some questions in the audience? At least I would like to start with one. So in practice currently, how important are GNSS signals for power grids? What is the, how broadly are they now used?
Depends. It really depends. If the substation is modern, there's probably GNSS involved in some form or another.
Okay, and these applications that you presented, which one of those are the most relying on GNSS now, and what would you say in the future would be the most?
Well, I think the wide area measurement systems will be a really big thing in the future, and they will really need accurate information.
Okay, thank you. Do we have any other questions from the audience?
Do you know, is it the case that you're using these do you know that you're using these GNSS signals to establish accurate clocks and maintaining the time locally, or are you using it sort of on the fly? Do you understand my question?
Yeah, and this is again the answer depends. So, basically, we are often using it from the source as is.
I see.
But we are also delivering it often through packet network systems these days. but the integrity of the timestamp is really critical factor.
Yes. Okay. Thank you.
Any other questions? If not, thank you very much, Jari-Pekka. And then we will take a little bit of a breather, namely we will rearrange ourselves so that we will start the panel discussion. So I would like to invite here on stage Mikko Stralendorf to continue discussion with us, and then we have Tero Vauraste continuing discussion with us, but we will have Tero joining from the train, so Tero will join remotely, and then new panelist we have Markus Ranne from Business Finland.
Thank you.
Welcome.
I think I need to be wired.
Yes, we need to find a microphone for you. Markus is the head of New Space Economy Program at Business Finland. And then we have Hans-Alexander Öst, Development Director of Vaasan Sähkö. So welcome, and let's make sure that everyone has mics, and then we will start with our panel. Do we have Tero online joining us? Not yet. Let's wait a bit.
Tero should have at least his mobile phone charged. Last night he didn't have a charger, so the hotel bailed him out. But that's why he does not have this very simple, sorry, no, no power, which would have been perfect for an energy week. Kind of like disappearance, I guess.
Yeah. Any luck on getting Tero? Working on it. Okay, so then we will start, and hopefully Tero can join in a few minutes. So, welcome our esteemed panelists, and hopefully we can also have Tero Vauraste joining us as planned, but online. We will focus on this panel on space technologies and their relevance for the successful energy transition. The energy field includes various types of stakeholders, such as governmental authorities, energy and utility companies, energy traders, and supply chain managers, as some examples. For them, satellite technologies can provide invaluable data under the form of various Earth observation and then also global navigation satellite system applications, as we have heard in the presentations in this seminar. And now in this panel, I would like to deepen a little bit on this topic, how space industry can most beneficially cross paths with the energy industry. How can our goals on climate neutrality drive the innovation in the new space economy? So let me start with an introduction to the panelists. So if I could ask each panelist to give short introductions, your name, organization, and then what is your current activity in the energy or then also in the space sector. Hans, would you like to start?
Thank you. So, as said, my name is Hans Alexander Öst. I work at the local energy utility company Vaasan Sähkö. Sähkö means electricity, but we do not do only electricity. We're also having district heating to the surroundings of Vaasa. And then, as regulated in EU and Finland, we have a subsidy called Vaasan Sähköverkko, so that's the local DSO for energy supply. A little bit about my background. I have 15 years of background in the energy sector and been also on the power plant sector for a majority of this time, so building and delivering power plants across the globe.
Okay, thank you. Then Mikko, want to continue?
Okay, if I continue. So Mikko Strandorf, I had the presentation, so I hope you already listened to that one. My background is very much that I'm a meteorologist. So weather forecasting, I actually have started my career at the Finnish Met Institute already somewhere in the late 90s, being really a duty forecaster and making the weather forecasts. But I pretty quickly turned into being one of those hackers to do the web services, for example, of the Finnish Met Institute, which so many of you are actually using. So thanks for that. It has been always a joy to have also real end use kind of like feedback. So doing these kind of services from weather moved me then somewhere to this point that I started to lead information systems at the Finnish Met Institute in general, but then I jumped to the European Commission, and I have actually been there at it was then called GMES, but nowadays it's Copernicus, and there was a team of 25 persons when I was fortunately be one of them to really just shape what the EU Copernicus program is all about. So defining the services, the space component and all of these things, that was very much a joy, and then I have been continuing to kind of follow that steam engine and make it just go faster and being bigger and wider and longer, and that's what I've done. But all the time I'm always keeping some projects on the side to do also the real development of services. So harvesttheseasons.com, you can check it out, is a service we are trying to do for forestry, so a little bit of bioenergy in a way. So when is it good to go into the forest to chop them down? Because nowadays we don't have the winter anymore so much. The summer has to be dry, otherwise it will destroy very badly the undergrowth, which is not allowed due to a lot of EU and Finnish legislation. So that kind of services I'm also involved in, but for example the coordinates thing, I was also involved to just get the data. These kind of things I do.
Yeah, thank you. And then Markus.
So my name is Markus Ranne. I'm from Business Finland, and I'm the head of the New Space Economy program. So the program is to develop the commercial activities of Finnish companies in the space domain. So both technology companies, but also application companies. And one specifically interesting thing is, like we're having today, is how to connect activities on Earth into the resources we can have available from space. So how to use space to develop our living and activities here. I have some previous space background. So I've worked for the European Space Agency for 10 years. And embarrassingly long time ago, I also had a connection to energy sector. So I used to work for a company called Evo Power Engineering, which actually has changed name now to Fortum in the meantime, and did power plant programming for automatizations for some years. So there is some power connection there behind me as well.
Okay, thank you. Do we have Tero online to join our panel? Not yet. Okay. Let's see. And now to kind of spark the discussion further, we have a video from the EU Agency for the Space Program, EUSPA, that focuses on sustainable energy. So let's take a look at that before we go to questions. Okay, then let's go a little bit deeper into these topics, and I would like to start with renewable energy and discuss about that a little bit with you and what your insights are. In the renewable energy sector, when we consider renewable energy assessment potential and forecast, power plant design and design optimization, risk assessment for energy assets, and then, for example, site selection, planning and monitoring for renewable energy. So I would like to start with asking, what are the more traditional ways to complete these tasks? And then we could go how space data could help. But Hans, would you like to start with opening a little bit about how traditional means are?
Traditional means, and this actually takes us about 15 years back in time when I started in the energy business, and I actually had my first summer job, and we talked about a power plant. I think it was in a small island called Tahiti, and back then, well, we took up a map and looked, well, Tahiti is practically on the other side of the globe, and what does it look like, and how does it see? And actually, Google had launched a service called Google Earth. So we didn't have Google Maps at that time. Today you open up Google Maps and you practically have 1-year-old image or anything like that. But we took up Google Earth, and with this fantastic satellite image, we could even see the power plant, or let's say the old power plant, and we could see the new power plant that had just taken into use. And a very practical example of how you from office space can move around to the other side of the world, look how it looks like, and start to imagine. Today, this is something you can use on all-day business. Take up, let's say, Google Maps, use images, think about how would it look like if it's in this position. Of course, that data is not enough. I think we had very good presentations about, let's say, on the topography and how can you place wind turbines. Is this a good location for solar PV panels? So very practical example of how you can kickstart a project and look for the right location for your new, let's say, renewable power plant.
And any comments, Mikko?
Yeah, I think
to add?
I already showed in the slides a little bit that there's also this very backward-looking available, and especially the ERA 5, so these reanalysis data sets, that goes back to 79, or I guess they are even not going to 50s. So you have a very long timeline of any kind of energy relevant. So there's the wind information, there's also the solar information. These things are all in that reanalysis data sets. So that for this kind of site placing, you don't first have to get any measurements itself. Just go to one service, cds.climate.copernicus.eu. You can already start from there. And then it's just more refining that information, and I think which in that sense makes it not difficult for the planning stage to do things. I think the challenges and something more to develop is really in this kind of where can we help also in the operation. Because I think there's, now that we are so frequently doing things again and again, it's not so difficult to think that we don't need so much instrumentation on the site, for example, to check out, like, is the solar field producing as it should? Because we don't necessarily have to have these measurements, which now usually are installed on site. You could just kind of leave some of that out and give it to a cloud system that is calculating this stuff for you. So in that sense, I think there's a lot of efficiency and kind of like small things that can be improved, or just make it sure that you have two sources of this information. So that's why I say there's lots of different small details, but they might be a kind of money maker.
Thank you. Markus, any comments also from the Business Finland perspective?
A lot of the things were covered, of course, in Mikko's presentation already. So if we're really looking at the renewable sector, we also have to look also outside Finland and what are the opportunities there. And then, even though snow is very important in Finland, I think when you move towards south, especially now with new EU policies and also looking at globally, having accurate wind maps and solar maps becomes very, very important in developing the renewables.
Thank you. And now we have Tero also on board the train and here with us in the panel. Hi Tero, can you hear us?
Yes, I can hear you well.
Okay, very good. We started with the renewable energy topic. So do you have anything to add what you heard the discussion so far? In your presentation, you already addressed this, but in short, the space data benefits to the renewable energy sector with respect to more traditional means.
Yeah, I could add one practical use case, which is using SAR data and tentatively also other Earth observation data to support the solar energy systems, whereas there's more and more like these large solar panel areas, and their condition and maintenance is something which is conducted from above. Currently with the help of drones, also from engineering from the ground, but also with helicopters and other flying stuff, which is obviously quite time consuming and also rather expensive. So an opportunity is to take benefit from SAR data also with that in the area of renewable energy.
Okay, thank you. Then staying in the topic on the renewable energies, kind of going towards zero emission economy more and more. So the most pertinent topic of our or of all during our times now is the climate change. So going to the role of space-based data and space-based or space technology, what role does that play there? So what future solutions related to climate change mitigation, also then environmental impact monitoring are most useful in your opinions?
Mikko could say that the Copernicus program is really let's say, we already have most available data for any free and open public source, but we will expand the Copernicus fleet. And I think the most important and first expansion is the CO2 mission. So we will actually, I think it's 2025 now, or as soon as possible for 28 to make a good kind of assessment of where are we at CO2 emissions. We have very good plans, and it will be a free satellite constellation that will monitor at 1 kilometer resolution all over the globe the emissions. And the idea of this emissions measurement is also that we make actually a distinction. These are human emissions, so we can tell then each plant, each operator in a way from this satellite system that this is what you are emitting. It's not anymore like until now that someone makes a report and tells something and then they might fool a little. Or at least the Germans did a lot of fooling a while back, a few years ago, that it was shown that by satellite observations it was a pretty different picture in reality, and next year the reports were a lot better. So I think this is where we're getting to. So I think there's also the knowledge that we are on this way, so that we can measure and follow up on this, we will get to zero emissions. So I think that plan is clearly there, but yeah, we will have to need some satellites up there more, and then it's going to be reality.
Yeah, data-based, evidence-based. Thank you.
I think with the climate change, we have also seen that the weather is more unpredictable. For example, year 2020 was very stormy in Finland, and that meant for our DSO that there were at times huge impact on the electrical network, and then impacting, of course, the security of electricity delivery. Was it in Tero's presentation we saw on the ISI that you can actually look through the clouds and down on a resolution of 25 centimeters. So today Vaasa, a beautiful area with a beautiful archipelago, brings some challenges to us because we have network out in the islands. During winter times it's very, very difficult to go out and inspect these power lines and see the condition. So I think there's a huge potential to use these kind of SAR satellites to inspect even just a few hours after after the storm, when you normally don't even can go out to the islands, and assess the situation. Where should we head out first, and where do we have big problems in the network?
Tero, do you have a comment on that application area?
Clearly in the train.
Yeah.
Maybe if I can continue on that. So indeed, of course, it's interesting to discuss what kind of information can be provided by various sensors, but what is equally interesting is the frequency with which this information can be provided. I'm sure that if Tero would have been online, he would have picked on this, because indeed the new space companies very often aim to the ability of being able to provide the information at regular intervals, frequently enough for it to be used real-time decision making. And in that respect, in some cases, it might be not so important what the resolution of a picture is, but when you get it. So that has an impact as well.
Yeah, yes. Thank you. Something kind of the evidence and data-based decision making also, where satellite data can come into play also with the zero emission monitoring, is resilience considerations as a whole. So and also Hans pointed out to that. So the energy infrastructure and then the space infrastructure, if we think about their crossroads and the resilience considerations. So what if we think that the space infrastructures become more and more important, also the energy industry? So what are the energy sector processes that could be then most affected if there would be some attack on the resilience of a space infrastructure, if we consider this time synchronization from GNSS, or then also some satellite imagery data? So what would be the largest effects of cyber security attacks?
I can start again. I think even without an attack, we have at the moment in the Copernicus program this situation that the Sentinel-1B has a power failure to the antenna. So on the 23rd of December last year. So since then, we are missing one satellite of a kind of like constellation that is very much used. And I think that already immediately raised the point of where are the other assets that can fill that void. Thank you very much, ICEYE, that, for example, you are one of those that are being utilized to do more. And I think that's why it is such a nice kind of situation that we do actually have new space and other capacities when only those kind of open free governmental things, because we can then buy from ICEYE and others to fill in as much as possible also that service infrastructure that is needed on a public good kind of way. So that's the point, but I think this is exactly the situation, and well, I just discussed with Tero that it might be interesting for us to also know that what is the status of their infrastructure, that we can take this in account in the European Union kind of picture, that we know about them, and then of course kind of helping that resilience is then an EU kind of task, and I'm sure that the program can, for example, finance some of these activities. It might be needed that just make future spacecraft more resilient to for example, attacks.
Now I think we have Tero. Do you have any comment? Have you heard what we have been discussing?
Yeah, indeed. So first of all, fully agree with Mikko, and important also to note in terms of cyber security and also infrastructural security is that there might also be things happening on the ground. So first of all, we have to recall that the information is still flowing during or through cables, and quite a short while ago we noticed that one undersea cable was cut for an unknown reason, where KSAT information was being brought from Svalbard to the continental Europe. So these types of threats also occur in this new geopolitical situation. And then one comment on to the previous discussion in terms of weather developments and disasters and flooding. So we recall the Hurricane Florian flood, which took place 2.5 years ago, where actually the wind really moved very rapidly into a new position and took a new path. And all the other satellite providers had programmed their satellites to another area, which in the end was 100 kilometers wrong. So the ICEYE's constellation was agile enough that we could satellites to capture images from the final destination of the hurricane.
Yes, thank you. Any other comments to this topic? We could then perhaps move on to the topic related to accelerating business. So how to boost space-related business and its wider entrance into the energy sector. So what is the role of open data with respect to then commercial available data? What should be done in the innovation policy side and regulation as well? How can we attract funding? And yeah, just in a nutshell, how could the energy industry collaborate more closely with the space industry?
So if I start, as I mentioned, I'm the head of the New Space Economy program. So what the program does is we focus on providing support to new companies in space sector and also more established companies in space sector which want to address new markets, but also the connection between the let's say terrestrial services and space services is very important, because the strong points like in for example in Earth observation, which Finland has, very much linked to what can be done on Earth. Space is very interesting, of course, at large, but if you look at the business prospects in the short to medium term, I think the most of them are on this globe and rather than elsewhere in the universe. Business Finland's instruments are, of course, some things that can be used to develop the business further. So we have our funding instruments, our international network, and also the invest-in activities which are active within the program. And we use these to develop the ecosystem in Finland. A practical example of joint operation, how that could be built up would, for example, be a co-innovation project where a combination of research organizations, technology companies and end users could jointly develop something that would address the end user problems. It is very important to go to the, let's say, to the core problems when these kind of things are being developed. So it is important that what is within such a development program or project is relevant to the end user companies. So it's not nice to have or something just that's fairly interesting, but it should have, in the end, of course, a large business potential behind it.
Mm-hmm. I think when I look at it from the energy market perspective and what's going on, so the day before yesterday we had in Energy Week a big wind power day, and today in Finland we're at par on wind power with hydropower. So hydropower learned that also today, that you monitor on water levels, how much do you have in snow, and that is of course something that we also follow. Hydropower is controllable, it's regulating power, but even in 1 year we will have more wind power from time to time in the system than hydropower, and in 2 years wind power will be the largest power producing assets in Finland on peak power. So that means we will need to get even better on forecasting. At the same time, today we are in 1 hour energy market, so we forecast on a 1 hour level. In May next year we will move to a 15-minute market. So we will need to improve also on the accuracy, how we can estimate on the wind power production. And I think here we saw on the data and how you can use the data combined by weather satellites, and also using then AI processes to be better on estimating the productions. I think here's really something to dig into, and I think we can still improve on that.
I can continue in that. The Copernicus program has actually also, for example, seasonal forecasts. We will just in a few months we will have these kind of decadal forecasts. So especially for kind of forward-looking investments, the picture is then not anymore the one where you actually are using what's the situation today and tomorrow to decide what's the price for something next year. Because I think this is a little bit what I know from the energy marketing, which is a little kind of like bizarre for me, because we are also producing information that actually looks forward in time. It's of course not as accurate and simple to use, because this is about a probability distribution question, not anymore a specific forecast. So in this case, we are getting more complex, but we have a lot of opportunity to actually be more wise while doing investments, or even like spot market buying energy from some operators. So I think this is all something to do. But I wanted to, what we try to do very concretely in the Arctic Space Center for the kind of like other businesses to spring up. Analysis-ready data is an idea that a lot of this free and open data is still not at a kind of level of processing where it's just like, yeah, just take it and start eating in a way. It many times needs kind of even heavy processing sometimes, and especially when you do it for all of Finland, for example, then it's not just a kind of, I can use my laptop and just wait the whole day. If this is something I need today, then it's too late. So we are doing some of these processings and making that data available. And I think that process is also being pushed in the EU Copernicus program overall, that we would have easier, and even a system where you don't have to have any kind of like storage place for this, any kind of the server infrastructure you need for your service is very light, because you actually just directly kind of pull, for example, to the browser of the end user, the data from wherever it comes from, and you just program that application. That kind of opportunities we are also trying to make, that it would not need such a kind of like have to invest in something first to be able to do a service.
That's also something in the Quarke Space Center that we are trying to promote, exactly. Yeah.
Maybe just to add, Mikko mentioned European Space Agency here being a delegate, and of course European Space Agency can support also companies not directly involved in space, which want to see how their business could be developed through space. So that's something that is good to keep in mind if really, for example, from energy sector perspective, you want to see what could be done in combining space and energy together.
Tero, do you have a comment on?
Yes, let me take another angle here. Both the European Commission and the European Space Agency have discussed widely about commercialization of space and new space approach versus old space approach. So entrepreneurs, startups, scale-ups are being encouraged to promote their businesses. However, there are certain contradictions in this. Simultaneously, there is now an initiative that our Italian colleagues are about to receive more than 1 billion euros funding from EU COVID recovery funds for a new space constellation. So this is in huge contradiction in a way, considering the fact that simultaneously there's an attempt to promote the new space companies, also with things like the Cassini program. Another contradiction is the difference between the governmental support and funding in the US and in Europe. So in the US, there is like a higher ability of providing governmental funding mechanisms to support startups in space. So the competition situation between different markets is not equal at the moment.
Okay, Mikko.
Just very precisely comment. I am fully agreeing with this, But the Italian question here is again that Italians get to decide how they use the money from the EU Rescue Fund. So that's a little bit that we need to try to see that as national countries we should also try to implement the idea we have in the EU, which I think is very clear. We want to help the new space sector and not make the old space kind of like just kind of destroy the market or something similar. Maybe that's too hard said, but in essence, I think the point here is really that it is nice that we have a lot of new assets to even build, but we should definitely see this kind of like in a fair system all across Europe.
Okay, thank you. Then I would like to open up the floor for questions from the audience. There's a question.
Thank you for this nice panel discussion. I would like to ask or take another angle because we are thinking or talking about a lot of new space companies and putting a lot of satellites, and you also mentioned putting a fleet of satellites to measure things more and more. But I have a concern about, let's say, like now, climate change is a very big topic because it's happening here, but there's also a lot of bad things happening in space. Like there's a lot of junk, for lack of a better word to use, so in space. So how do you deal with it, and what are your organizations doing to kind of mitigate the problem of space debris?
Do I need to answer here? Yeah, fortunately it's a little bit more my colleagues, but the Finnish Met Institute, we are involved in networks of Finland, which actually it's I think University of Helsinki and Aalto University and many others, maybe even Vaasa. I just can't remember who all is in there, but there's a center of excellence that is looking into this problem, and I think we are actually quite forward-looking in the sense of Europe in this whole business, because we do have the small sat industry so well represented that we understand the threat here better. But the point is that we need to monitor, of course, what's the situation up there, and here we try even to use old big antennas we have in Tähtelä and Sodankylä to be able to have this kind of close near Earth space segment where the satellites are moving, that all the small kind of pieces of junk could be monitored so that we can see when and where to evade things, because the problem is really that you can't take it away very easily. It's not like it's all over. But it's still, this threat is there, and we try to just be able to warn in time to get people out of the way. And this information needs to be much better kind of, I think, available, because, for example, these ISI-like kind of private entities are also involved. So this cannot be anymore the kind of NASA is doing and telling to their colleague organizations in different countries. I think this kind of, the perimeter of where this data is shared is growing.
Markus.
So, okay, Mikko mentioned the Center of Excellence. So Helsinki University working on the sustainable use of space. So that's, let's say, on a national level is the most expertise we have on space debris. The way Business Finland addresses this is through companies which provide solutions for this area. So for example, one of the companies we work with is called Aurora Propulsion Technologies. And indeed, it was already mentioned here that it should be possible to guide the satellites even though they are smaller. And of course, that requires very small engines. So Aurora Propulsion is addressing exactly that problem. So they manufacture miniaturized engines to guide or direct nanosatellites and small satellites. And also they have a solution which is a plasma leash. So at the end of satellite lifetime, instead of just having the satellite hanging around in the orbit, you let out the brake and then you are brought to the Earth's atmosphere and burn up on entry, and no debris remains on orbit. So these are some of the solutions available.
Any comment from Tero? No?
Yes, obviously there's been a huge amount of new satellites launched last year, more than 2,000, and we're expecting the number to grow a lot within the next couple of years, bringing the whole number of the satellites up to 20 and to 30,000 with the next 5 years. So indeed, first of all, international collaboration and regulation is required. It's not there in the full place at the moment. What ISA is doing is that we are moving more and more to sustainably produced materials on our satellites, also taking into account that the solution itself already is sustainable because of the fact that the satellites are very light, and it means that they consume less energy compared to the old space satellites.
Yeah, thank you. We are running almost out of time. Oh, where did the time go? It was so nice to hear your insights. As a final kind of word of advice from you, I would like to hear, how do you think, what would be the best ways for us here in the heart of the energy cluster in our region? How could we, the stakeholders here, enter the space race? Any advice?
Well, if I start, this is a really difficult question for us as an energy utility. So space is there, but it's quite far from our center of work. We wish to continue the cooperation with, for example, University of Vaasa, and by that to be supportive and to continue to support that we can, from, let's say, the local energy utility, also give our straw to the stack.
Thanks.
I am very practical. I think as there is lots of data out there, just go out and put some people, even at an energy utility, into looking into what data is there, and then that might already just say, we could use this. So I think exactly. this kind of simple, and get more students, put more people into working with space data, which actually then will trickle up even into how do we build these satellites and how do we have more specific ones. I think all that comes from the fact that let's just try to utilize as much as possible and find new ways.
Thank you.
Well, Vaasa is of course in a bit of a privileged position now with having Kvarken here, so there's a sort of direct connection between space and the other industries. One additional path that I can think of is the Space Business Forum, which is organized 5 times a year by Business Finland on behalf of the National Space Council, and that has the purpose of bringing together space companies especially and providing information how to develop their activities. I think there is no problem if an energy company that's interested in connecting with space companies would like to also attend that kind of forum. I think it would be a very good idea.
Yeah, thank you. Tero, any final words?
Yes, for this particular question, collaboration between universities, user companies and space companies is the key. So, for instance, this initiative by the University of Vaasa and the whole energy cluster in Vaasa is really welcomed and paves the way forward.
Yes, thank you. So with this, we conclude this seminar powered by Space. A warm thank you to you panelists and then all of our speakers and the organizers here, that we have had a great team here. And thank you, Energy Week. We hope to be back next year on the same topic. Thank you.
Thank you.
Thank you, Heidi. Well done.